In this new set of series, I'll be looking at the Keras code examples, which I highly recommend. Keras has a lot of examples code that helps give a better understanding of the concepts that we read in research papers. So, in the new series, I'll be taking up some of these walkthrough examples and I'll be modifying them to add my own intuition to them. So, the first one we're looking at is the autoencoder, and you may want to read more about it. And I have a blog post on this modification, which you can read here, and the link will be in the description below. So let's look at what actually was added to here. Originally, the code as it was written by the original author is to create an autoencoder for MNIST images, and in the latter part of it, he also developed the code so that he can remove noise from a noisy added some noise to the image and tried to remove noise from it, and that's what actually done it. So this was the noise that was added to this image and trained the autoencoder so that it can recover the original image while removing the noise. So in my own case, I have modified the noise part of it. So basically this is where I worked on, and what I did was that I tried to max out some pixels in the channels. So here you have, this is the channel uh, of the images. So this is 28 by 28, is 6000, 28 by 1, as you can see here. So what I did was, this is where this grid is, this matrix is 28 by 28. What I did is I tried to max out some pixels from here, that is from the rows, and I maxed out some pixels from the column. So if you look at an example of what has been maxed out, you will see these two. So these pixels were maxed out, and this was maxed out, and you can see the rest like that. So now the goal now is to actually give the model this bottom maxed out. We give it this perturbed image, and we expect the model to be able to fill up the missing maxes. So if we look in here, you will see that we now train the model. This is the result of training the model on the noisy ones. So this is where we are now doing the prediction. So when we give the model this, you see it did a good job of reconstructing this. So well, it's even very difficult for a human to know that this is 9, and it did a good job of reconstructing this as 9. And even this one, you might think this is 0, so it's do a good job of getting as a 2. And this is 8, you can see a good job of bringing 8 out. This is 2, and this is 5, and I almost got it very correctly here. First, this is 5, did one, and so this is 6, and he got this 4 correctly. So, and details of how it is trained, you can see it. So we feed in the perturbed at the encoder, and we expect the image to reconstruct the unperturbed one, the clean one. So in the process, it learns to be able to fill up the missing pixels in the input. Alright, so you can read more about it in the blog posts that I showed earlier here. Interesting usage of Autoencoder. Thank you very much, and see you in the next one.